In this presentation, we will review how a strain carrier wave starts, how it backs formation of a brain activity, and how it terminates, as well as how its post activities like memory building and consolidation happens. In this study, same as was mentioned in other videos, two significant parameters back a brain activity emergence. A strain energy wave circulating around the cortex in general is the first one. This wave include the clouds of the strain packages, which some of them lock together and coagulate a short-term memory. Second is the radial inputting to the cortex layers that activate neural networks to emit strain packages in the strain carrier waves. Circulation of the strain carrier waves around the cortex needs a driving force to travel. Potential that pushes a strain energy to travel is a strain residual gradient in location among the pathway. This gradient varies by time and location depending on functional viscoelastic property that changes by increase and decrease in strain residuals. As already told, strain energy circulates in clouds of strain packages among strain carrier waves around the cortex. However, some strain packages float more freely from each other, while some others coagulate together, constructing a structured streams as short-term or working memory. The potential gradient of the strain residuals around the cortex layers is based on activation of the neural networks that will activate by radial communication of the limbic system with the fourth layer of the cortex. It is not only the communication of the radial and circular strain streams through the cortex layers that are important, but the intensity of communication with different cortex areas will determine how dynamics of the gradient will vary, and thus the strain energy speed and kinematics will rise. Different ranges of the strain energy kinematics will maintain different brain states, changing from deep sleep at lowest kinematics to focus waking at highest kinematics will happen. The length and lifetime of the form short-term and working memories are tightly connected to the strain energy flow kinetics and state of mind. States of mind in general are categorized as deep sleep stages 3 and 4, intermediate sleep stage of non-REM 2, Dreamium stage of REM. Sleep stages will be repeated in 5 cycles. Then there are relaxed waking and focused waking, that each of these states may split in substates depending on the degree of the cognitive tasks are going on during those states. Ratio of the radial communication between the cortex and the limbic system, as well as between the cortex areas, are the main parameters in determining the brain state, considering that all these communication are not only because of current state strain lobes, but the strain residuals remain from before as well. A typical stress straining curve, which indicate viscoelastic property of the location, is valid for a neural assembly in any cortex location, as well as a train of neural assemblies along a pathway, and finally the global brain activity that is made of a complex of pathways. Viscoelasticity is not fixed in any location. It varies with time, but this variation is within a range depending on the strain residual that is accumulated in the location. Furthermore, chemical plugs like in Alzheimer's disease and or fatigues of tissues may seriously affect viscoelasticity problems. A typical stress straining curve indicates how much straining will happen where stress force impact the tissue. Connectivity tissues exposed to very small stress fields may have not enough force to strain a tissue to a sensible range. In tau range of stress straining, the stimuli may not attract attention and even initiate a brain activity. By increasing stress force, strain will increases proportional to and in a linear manner with stress. In this range of the current brain activity normally would not leave any strain residual to consolidate a memory of that activity later. The neural assemblies along the pathway conduct strain energy to other assemblies as they receive that. If due to different strain storing capacity or accumulated strain residual in some places, strain energy conduction would be limited. Stress straining happens in the non-linear range in this case. It means that local connectivity tissues should absorb some strain residuals. This absorption is not unlimited and beyond the capacity in location may consolidate connectivity in a disordered way, disturb fractal structure in the location, and even damage tissues. If fractal structure disturbance will cause memory malfunction and nonsense integration of memory units in thought generation. In any way, brain activity needs strain energy streams to follow around the cortex through cortex areas and connect relevant memory units to generate it out. This needs a stimuli, internal or external input, to initiate a strain energy flow, to expand through one or more pathways over the cortex. Within linear range of the stress-straining correlation, connectivity configuration will return to resting position when strain energy flow stops. Within nonlinear range, a similar phenomenon happens, except the connectivity configuration will not return to original position exactly. But about that, beyond the nonlinear point to the tissue yield point, this is the range that the memory consolidation in deep sleep happens. But if it occurs in waking time, it may damage the brain tissues and would initiate a physical disorder. Beyond the yield point of tissue straining, it may cause tissue injury and rupturing as well. In this slide, the high potential strain that initiated brain activity is illustrated. It can be a sensory input or a high emotional input created internally in the powerful activity stimuli, like in the previous slide, will start a flow of strain energy over the cortex, as well as radial emissions from thalamus and other components in the limbic system to the cortex locations through layer 4. A resonation between circular strain energy currents and radial inputs to the cortex areas will make the involved neural assemblies to coagulate and form short-term or working memories. The length of activity and lasting period of it depends on the length, complexity, and lifetime of the formed memory. As it was mentioned before and will detail in future presentations, strain energy pathways are different in different brain states, and they form a short-term memory length and lifetimes will be different as well. Consciousness is the process of fully blending of forms and moves, and the brain is the only advanced natural media that can unify an observer and observee in one unique frame and emerge consciousness. Consciousness about object characters in a brain activity like self and others, consciousness about layout or scene that characters play in, as well as their behaviors and interactions. This kind of the consciousness is categorized as sensation and perceptions. Consciousness about how stressful the event is feeling, and consciousness about brain cognition products like decision making or choosing or arriving in a conclusion will emerge a global awareness of the activity in the whole brain. Among different unconsciousness types that appear during a brain activity, there is a peak in consciousness intensity, which is referred as the image center of the activity. This peak point happens where and when a strain residual load arrives in its climax and maximum amount. In observation activities, it is sensation or perception or a combination of both. In analytical and concluding brain tests, it is cognitive process and cognition. In emotional tasks, it happens in the limbic system as feeling. In dreams, image center is a combination of perception and feeling happening between temporal lobe, temporal cortex, the medial temporal cortex, and hippocampal system in the limbic system. Again, consciousness intensity, brain activity strains, and strain energy dynamics and kinematics are the parameters that are tightly connected to each other. As a summary, by expansion of strain residual in a location of input, a brain activity will start to develop. The activity may rotate several times from the cortex to mature sensation, perception, feeling, and cognition in sequence. After termination of the activity, the remaining strain residual of the activity may build a memory of the activity in an arrangement that long-term memory structure dictates, meaning similar memory units will be located around each other or over each other as motifs in a fractal local structure. Consciousness along a brain activity has an image center. In dreams, the image center is where emotion in it is maximum. The symbols in dreams are similar memory units that are consolidated in same location. In the end of the Dreamium 10-2, please note that numbering of the presentation, if they are more connected to each other, will have the same number with different sub-numbering. Please do not forget to send your comments and questions to mostini@gmail.com. Thank you.